The Atomic Theory Reading Passage. Around 440 BC, the Greek philosopher Democritus first stated the idea of atoms. He proposed that if a substance was repeatedly divided into smaller and smaller parts, there would be a point that would be reached where the substance could not be divided any further. Democritus said that matter is made of tiny solid particles that he named atomos, which means indivisible or uncuttable. At this early stage, the idea of an atom was very simplistic. John Dalton was a schoolteacher in England who enjoyed chemistry as a hobby. In 1808, Dalton used his detailed notes to propose the first true model of the atom. Dalton said that atoms were hard, dense spheres that were indestructible. He proposed that atoms could not be created or destroyed, and believed that atoms of one element were exactly alike, and that atoms of different elements were different. In 1897, J.J. Thomson discovered that atoms contained negatively charged particles called electrons. In Thomson's model of the atom, these negatively charged particles were scattered through a ball made of a positive charge. His model is often called the plum pudding model because the positively charged ball resembled the pudding, and the negatively charged electrons resembled plums in the pudding. Around 1909, Ernest Rutherford did a series of famous experiments that involved shooting a beam of positive particles at a piece of thin gold foil and observing what happened. Rutherford's experimental data suggested that an atom is mostly empty space, with the electrons moving around a dense, positively charged center that contained most of the mass of the atom. Rutherford called this positive region in the center of the atom the nucleus. He also found that the nucleus contained positively charged particles, which he named protons. In 1913, Niels Bohr used Rutherford's experimental data to show that negatively charged electrons move around the nucleus in particular energy levels or paths according to the amount of energy they have. According to Bohr, the electrons were like planets orbiting the sun. Each electron path is a certain distance from the nucleus. Electrons closer to the nucleus had less energy. Electrons further from the nucleus had more energy. In 1932, James Chadwick, a student of Rutherford, discovered a second particle in the nucleus. Rutherford was the first to propose that there must be a second particle in the nucleus, but he did not find it. Over 2 decades later, Chadwick discovered it and called it the neutron. This particle was particularly difficult to find since it had no overall charge. It was neutral. The modern atomic model features a number of small changes to the existing model. Several scientists determined that electrons were not found in certain energy levels, but in a hazy region around the nucleus called the electron cloud. The modern atomic model states that the atom consists of a small, positively charged nucleus containing protons and neutrons, and is surrounded by a cloud-like region of negatively charged electrons.